So what is recursion? As you know, recursion in C language is nothing but a function calls by itself. Look at this program. This program is to display numbers from 3 to 1 without recursion using loops. Check the program once. What is the name of the function? The name of the function is fun, and this is our prototype 2. This is your function definition. Function with one parameter, and that is y. So while y greater than 0, print y and y minus minus. This is your definition. And this is your function call. X is your actual parameter and y is your formal parameter. The value of x is 3, so 3 is passed to y, and 3 greater than 0 is true. You get 3 printed on screen, and y becomes 2. Check the condition. 2 greater than 0, 2 will be displayed, and y becomes 1. 1 greater than 0 is true. 1 will be displayed, and y becomes 0. 0 greater than 0 is false. So this is a program without recursion, using loops to display numbers from 3 to 1. See the time complexity and space complexity of this program. Now what is tail recursion? A recursive function is called tail recursive if the function makes recursive calling itself. A function called by itself, and that call must be the last statement in that concerned function definition. And after that call, there won't be any other statement inside the function. So we'll see the simple example. So look at this, the same program using recursion, and the name of the function is fun. If n is greater than 0, printf n. So 3 will be printed. Look at this call. This is your function call. You are calling for n minus 1. So means you enter the function definition with 2. As 2 greater than 0, 2 will be printed, and 1 greater than 0, 1 will be printed. Once it becomes 0, 0 greater than 0 is false. You just come out of the function. And this function call is the last statement of the function definition of the recursive function. Here the name of the function is fun. This is called tail recursion. And the output is 3 to 1. So look at the tracing notation here. fun of 3 is called, that is the order 1. You can see the order 1, 2, 3 in red symbol. The function is called for 3. 3 will be printed, and again for 2, and again for 1. When is for 0, the condition is false. You just come out. And the time complexity and space complexity is given. See the example. Start with the main program, and the value of x is 3, and this is your function call, and 3 is passed to n. 3 greater than 0, printf n. 3 will be printed. Now again we have a recursive call, fun of n minus 1, that is fun of 2. So you enter the definition with 2, and 2 greater than 0, printf n. 2 will be printed. And again we have a recursive call for 1 greater than 0, printf 1, and again for 0 greater than 0 is false. So one important thing is why the space complexity is less in case of loop. So we have two programs, one using loops and one using recursion. So as you know, when you execute any particular program, the memory is divided into three parts. One is for code section, second one is for heap memory, and the third one is for stack memory. The program can directly access only the stack memory. We can't directly access the heap memory. So we need pointers to access the heap memory. So in case of loops, when you use the function, it executes there only one activation record created in stack memory, created for only y variable. So it takes only one unit of memory inside the stack. Whereas in case of recursive function, whenever you call, every time it calls itself. For each call, a separate activation record is created in stack. So if there is n number of calls, we need n unit of memory inside the stack. So that is the difference.